All right, as promised, I'm going to do a walkthrough of some of the Wiresharky things that you could see. And again, don't worry, if a lot of this stuff is unfamiliar to you, it's all brand new. You'll pick it up and more of this will make sense the longer we go on in the semester. As a brief reminder, this is the stuff that you are expected to have in your packet capture. So make sure you start the capture, run through all these things, and then I am going to look at most of these things. I'll probably skip the other website part because that'll be different, and that's just a chance for you to explore what's going on. But we'll look at an AWS site, an unencrypted website, visiting robots.txt, which is an encrypted page, and seeing what that looks like, the ping messages, and client.py, and what you get and see when you do client.py. So let's go ahead now and open up Wireshark. And this video will probably be a little bit less polished than normal because, well, to be honest, I'm just kind of flying through it, making this up as I go. So we will see what happens. Okay, so the very first thing we want to do is look at that unencrypted website content. And the easiest way to do that is to just look for HTTP. So up in the top of the window here, you'll see add a display filter, and go ahead and just type HTTP right there. And you'll notice you visited a couple websites. You visited robots.txt and you visited your unencrypted website. And as long as you visited the HTTPS version of my robots.txt, you will only still see HTTP for your visit to the unencrypted website. And we will talk about that when we look at the contents and we look at what happens when you visit the encrypted version of my website. So what we can see inside of Wireshark here is exactly what the layers that we've talked about. So you'll notice down below, we've got the binary data that was sent across the wire represented as hexadecimal, which is an awesome way to represent binary data because one hexadecimal digit represents 4 bits perfectly. We'll talk about that more when we talk about the physical layer in a bit more depth. But you can see the different layers, starting with frame, which is the physical layer. This is the information about the physical stuff that was going on, including when exactly the bytes were transferred across the wire. Super low-level stuff there, exactly what network interface that was captured on, all of that information. Then you've got the data link layer stuff. The data link layer is actually the first bits in the packet because the physical layer doesn't actually have any addressing or information of its own. It's just the ones and zeros and the electrons and the light flashes and all that stuff that gets the information transferred. So the data link layer, we've got Ethernet, and we'll talk about that later. Then after you've got your Ethernet stuff, the most outer encapsulation, then inside of that, you've got the network layer stuff or the internet layer stuff, including the IP protocol information and addresses and all that stuff. So that's the second layer of encapsulation. Then you've got the third layer of encapsulation, the transmission control protocol, TCP, at the transport layer. And then finally, you've got your application layer data. And in this case, HTTP has a whole bunch of information, and you can see it down below. You can look in the bytes and see exactly what is said there, or you can watch Wireshark format it nicely for you by clicking that little down arrow next to the protocol, and you can see all of the information that was sent along with the HTTP request, which is when I type, the IP address of my website to try to get to it, I send an HTTP request to the website, and the website responds. We are looking at the request that I sent, and I have sent information about what I accept and what kind of encoding I accept and the user agent, what browser I'm using. And you'll notice a whole bunch of junk in there that seems maybe irrelevant. You've got Apple WebKit, you've got Chrome, you've got Safari, all of that. User agent stuff is extra. I was using Chrome in this case, and you can see it's Chrome version 88.0. whatever. And we can look at the request itself. It's a request using request method get, request URI. More of this will make sense as you learn about the application layer very, very soon. So we've got that, and then in response, I get an HTTP response. An HTTP response 200 OK, meaning this is good, and this is all HTTP header information. All of this here is header information, and then you've got the actual contents of the site. And you can look at that and let's see, if I make this bigger, you can look down and see the actual HTML, tab, head, new line, all this stuff. I have a website and the contents of the page. So you can pull this up if you want. You can go to my website at 100.26.206.96 and see the website for yourself. It's not all that special. You can see the contents of it here. And so these, all this information is contained within a packet that comes to your server. And that's HTTP. So now that we've looked at that and started to get a look at what HTTP looks like, let's clear that. And now that we've cleared that, let's have a look at what you see when you visit my website and specifically see that robots.txt file. And if you clicked the link or typed in https://schetzler.net robots.txt, you will see it's a very short file. It's just a couple of lines of text. It's raw text. And all it is instructions for web crawlers like Google's web crawler bot or Bing's web crawler bot or whoever else is crawling the web. It's kind of a courtesy file that I can say, hey, I don't want you to look at this part of my website. In my case, my whole website's wide open. So it just says, hey, come look at my website. Anyway, the file is super short, but I want to see exactly what was sent to make that file show up. And it was another HTTP request, but it was an HTTPS request rather than HTTP because it was on that encrypted connection. So I can't just type HTTPS. And the reason for that is because it doesn't look like HTTP as far as Wireshark is concerned. And we talked about this a little bit. Things that are sent over HTTPS are encrypted. And so the contents of that and the exact format of the request is completely encrypted, invisible to Wireshark and thus to anybody else listening on the network who might be able to intercept what you're doing. So what I need to do instead is look up the IP address. And the first thing I can do to do that is go to DNS. And I have the IP address, but I'll just show you how I got it. If I look for in the DNS requests that were sent while I was connected, and you'll notice there's a whole bunch of them, and this is all getting the IP addresses because we use names like schetzler.net or in this case ssl.gstatic.com or whatever, but computers use IP addresses. So I sent a DNS request for www.schetzler.net, and if I look at the response here, I can see that www.schetzler.net is actually at a couple places, but the one that we're going to look at is 104.21.13.109 on this line right here. So I am now going to look for ip.addr equals 104.21.13.109. And this is the request that I sent for HTTPS www.schetzler.net/robots.txt. And look at all that stuff. There is so much stuff that it takes to do that. And the reason for that is, as you're probably learning about in your security class, you have to do a key exchange when you're doing HTTPS. There's passing information back and forth to set up the encrypted connection, and then we send the data, and then we close the encrypted connection. And all of that is here. So we've got, let's see, is there a easy way for me to count the packets? Looks like 24. You can see at the bottom right-ish, in the very bottom bar, I can see that I have a total of 2,316 packets. 24 of them are displayed. So 24 packets it took for me to get robots.txt. Most of that is overhead setting up that connection. And we've got packets being sent. So the ones that just say TCP, are just overhead for the transmission control protocol to do its job. All stuff we'll talk about when we talk about TCP. And then we've got the TLS part, and that is the encrypted connection. So here we're setting up the encrypted connection. Here the server responds and says, hey, I got your stuff. Here's some application data. And if we look in the application data, HTTP over TLS, that's all we know. All we know is that we're sending HTTP over TLS. We cannot see the contents of this in any way, shape, or form. You can look at the bytes and see that it's a bunch of jumbled gobbledygook. It's ciphertext. We can't read it, and neither can anybody else who's listening on the network, which is pretty handy. We've got changing ciphers. We've got application data. We're not going to get into the details exactly of how HTTPS works. Hopefully you'll cover that in your security class. But all you can see, what I really want to highlight here is that even though we're just visiting this one little tiny file, we have a whole bunch of information here and no way of piecing it together, figuring out what the contents of that file is. And even though it's a very tiny file, we've got a whole bunch of jumbled ciphertext here. So it makes it even harder to figure out what's going on. So that is our encrypted website. Pretty simple. So now we're going to clear that filter and look at a ping. And the pings, again, not a lot of super interesting information in a ping, just wanting to show that it's happening on the network, obviously, and what's going on there. So pings use the Internet Control Message Protocol, ICMP. So I can go up to the top bar, type ICMP, and hit return. And you can see that I have 4 ping messages sent and 4 ping messages received. So the requests are what I'm sending. The replies are what I'm receiving in return. And if we look at the contents of ICMP of the message, we've got our, sequence numbers that we sent messages, and we're getting replies. And the data is just some dummy data. Looks like 0809, 0A, 0B, 0C, 0D, 0E, 0F, 1011, etc., all the way up to 37. And that is just what it takes. So a ping is just a message that your computer sends out to say, hey, are you there? And the reply is a message that is sent back that says, hey, I'm here. And that is the extent of what we're looking at here. So you can see the contents of the ping. You can see that it's just kind of filled with some dummy data. It just sends some data that the server can send back to say, hey, got your message. There we go. And the very last thing that we're going to look at is the Python client.py. So this is going to be another one that is sent to that same IP address as my HTTP, because in my case, my web server is the same as client.py as the client.py server. I'm hosting them on the same thing. In your case, your server is probably something different, but your client.py is going to the same address of 100.26.206.96. So what we're going to do is filter by IP address, and we do that by typing ip.addr equals, and in this case, it's going to be 100.26.206.96. And we can see everything that was sent. All of this up here, all of these things here are related to the HTTP message that was sent. And down here, we've got client.py. So you'll look through here and you'll see some file or some packets have no application data. You can see frame and Ethernet and Internet Protocol and Transmission Control Protocol. And that is, again, part of the TCP overhead. Part of what it takes for TCP to do its job is just to send these messages, to set up the connection to the server. And then once you click through those or scroll through those, you can hit the down arrow, you'll find one that has the actual data. And you'll notice in my case, I sent the message howdy doody. And you can see inside there the message howdy doody. So there is all of this encapsulation. Down here you see howdy doody. All of this before that is either Transmission Control Protocol or Internet Protocol or Ethernet header information. All of this is encapsulation, those envelopes that are encapsulating the information that enable it to be routed across the network, routed across the local area network, onto the server, onto the application to get where it needs to go, to be able to send howdy doody. And then howdy doody is sent, and if we scroll down a little bit more, we'll see some more overhead, and in response, you can see a message in return that is capital howdy doody, which is what the server does, and again, still all of that overhead. And then finally, even after that, you'll see, I think we're looking at 537. If we look at the packets after that, all of that is required to close the connection to the server. So just to send that little tiny message of howdy doody to the server and capital howdy doody back, we have 11 packets sent across the network. It didn't take very long. You can see it started at 28.79 seconds, ended at 28.94 seconds. So it took less than 0.15 seconds for the whole thing to happen, but we had to send a message across, set up a connection, send the message, receive the response, and then close the connection. And all of that happened in about 0.15 of a second, which is pretty dang impressive, especially considering that all of this is happening communicating between my computer here in Utah and a server somewhere in Ohio or Northern Virginia. So that's pretty awesome. Anyway, that is Wireshark. The best thing for you to do is to practice putting in some of these filters, checking out what the filters are. You can even try some filters of your own, look around, see what you can find, scroll through the packet list, see if there's some packets you don't recognize. And there's probably lots of them, and figure out what those are, or maybe start to try and figure out what they are, or even just what some parts of those are. And that's our intro to Wireshark. Hopefully that all starts to make some sense. Again, don't worry if a lot of this is confusing. We haven't talked about HTTP. We haven't really talked about TCP and IP and what they are and what they do. So don't worry that those don't make sense necessarily yet, but just start to get familiar with looking at them and seeing what is involved in sending information across the network.